Hi, my name is Richard Duffy. I'm the Small Enterprise Solution and Enablement Manager for Asia Pacific and Japan. In this Tech Tip session, what I'd like to do is give you a little bit of an introduction to performance monitoring and logging. One of the questions that I often receive from partners and internal SAP team members is how do I go about starting to debug or starting to try and understand what's happening in a particular server that I'm running that seems to be having some performance issues. So in this session I'd like to take you through some of the basic tools for doing that. So what are we going to cover in this session? We're going to talk about using Performance Monitor, or also known as System Monitor. This is the fundamental tool that's provided by Microsoft for running performance monitoring, logging, and making sure that you have access to the information about the server that you're running and what's going on that server. Then I'd like to spend some time talking about specifically working with the Performance Monitor and SQL Server 2005 in particular. We're going to have a quick look at some of the performance counters, what they mean, what they tell you, and importantly, when you get some results from those performance counters, what specifically you can do with those results. What are the things that you can do to address some of the performance issues that those results might be telling you about. We're then going to talk about building a baseline, what a baseline is and what you use a baseline for. And then we'll go on and we'll talk about a nifty little function within SQL Server performance monitoring called user settable objects, and talk about how you can potentially use those with SAP Business One for debugging or logging or monitoring some specific activities that happen in SAP Business One. So again, Performance Monitor, you may be familiar with the tool. Performance Monitor is a tool which ships with just about every version of Windows. It ships with Windows XP, Windows 2000, Windows Server 2003 and Windows Vista, albeit the look and feel of the product is somewhat different depending on which of those products you're working with. Fundamentally, it's built using the Microsoft Management Console. And what that means is you are not only able to incorporate performance monitoring, but any other MMC compatible plugins you can potentially add to your performance console. So, when we're looking at working with the Performance Monitor and SQL Server, there's a couple of best practice examples that I've put together for you, and a little bit of guidance around using Performance Monitor with SQL Server. So first thing you want to do with Performance Monitor is obviously you're going to be using Performance Monitor to see how the server is behaving over a given period of time. Now, again, you can run Performance Monitor for any period of time that you want. If you just want to run the Performance Monitor for 1 hour to see what happens with the server when the users are doing a particular function on Business One, you can certainly do that. But one of the things that we recommend you do if you are having a server where you think you might have some performance related issues is we recommend you create a 24-hour log that you can start to do some analysis against. So, suggestions: pick a typical business day. Don't try and do this on obviously a weekend or a holiday and expect that to give you a little bit of an indication of how the server might perform on an average day. So, as I said, one of the other things you can also do is you can specify that you want to create an analysis log when you're performing special activities. For example, if month end causes you some particular performance headaches, or at the end of the day if you're in a distribution organization or your client's in a distribution organization, and when they do their end of day pick and pack and in preparation for shipping at the end of day, they want to see exactly what's going on with the server at that particular point in time. Of course, you can go ahead and you can specify to do a performance log for that period of time. So what do you want to do? What I've done is I've put together a little bit of a table for you just to identify 8 of the most common areas that you can look at on a machine running SQL Server to tell you whether or not potentially you have some kind of bottleneck, whether you have a memory bottleneck, whether you have a disk I/O bottleneck, whether or not you have an issue with your CPUs. Maybe you don't have enough processors in the machine. So what I've done is I've put together this information, and what we're going to have a look at is we're going to go ahead and we're going to build a performance monitor, and we're going to capture this information. So you can then take the information that you get out of that performance monitor and pop it into this table. So then you can go ahead in a standard 24 hours, once you've got these core baseline specs, if you like, you can then compare the results of this with some best practice guidelines on how SQL Server should perform. So what I'd like to do now is go ahead and dive into a little bit of a demonstration of building or using the Performance Manager to go ahead and build a performance log. So let's go ahead and we will build a little bit of a performance logging view within Windows Server 2003. So what I've got right now is I have a machine, a relatively low powered machine that I'm running in my house, along with 2 or 3 other servers that's running SQL Server 2005. It's also running Windows Server 2003 with all the necessary service packs for SAP Business One compatibility. And we're going to go ahead now. We're going to start the SQL performance monitoring. So how do I get into that? Well, all I have to do is click on Start and go into All Programs, then go into Administrative Tools, and then I can go into Performance. Now what the system will do is it will go ahead and it will start with a baseline set of performance counters for me. So let's just go ahead and expand that out. Let's expand out so you can see which specific objects I'm utilizing and which specific instances I'm utilizing, and what are the counters that I'm utilizing. So again, a couple of quick points just while we're on here. Again, it's usually a recommendation not to run performance monitoring from the machine that you're actually doing the monitoring of. What do I mean by that? By using the performance monitoring tool, you're able to connect to an external machine and capture the performance monitoring counters from that external machine. Main reason that you might want to do that is running performance monitoring itself actually has some overhead, and you don't want to skew the results that you get in the performance monitoring because of the fact that you're running the performance monitoring on the same server. What you're trying to do is get an accurate picture of what's really happening on a day-to-day basis with that server. So, what are some of the counters that you'll want to have as part of this process? Well, the first one we want to add from a memory perspective is our number of pages per second. What this counter is going to do is going to measure the number of pages per second that are paged out of RAM to the disk or paged into RAM from the disk. So again, this is potentially what you might have heard of as disk swapping. So how do we add a new counter? Really, really simple. All I do is I go up here and I click on my plus sign, or I can choose Control I. In this case, I'll click on my plus sign. Now again, this is where I'm saying I can select the counters from a different computer. In this case, I'm going to choose it from my local computer, and then you specify the performance object that you want. And in this case, we're going to be looking at our memory. So you can see these are all the counters that I have. So I choose memory, and then I choose from my list, I'll go ahead and choose my pages per second. So there it is, there's my pages per second. I choose Add. Now it's just telling me, hey, guess what? You've actually already got this in your basic performance log, so it's not going to add it again. So go ahead and say OK, and you can see down here I already actually have my pages per second being logged. Now if at any stage you're looking at one of these counters and you're thinking, well, exactly what does this counter do? You can simply select it and choose Explain. Alright, so and you get a little bit of an explanation from Microsoft of specifically what this particular counter is managing. The next counter that you want to add is your again a memory counter, and we want to look at the available bytes. So let's go ahead and choose that. We'll choose available bytes and we'll add that, And you can now see my available bytes has now been added to my selection of counters. Now, what's the purpose of the available bytes? This is really to check how much memory is available for SQL Server. If you're running a server that's dedicated to SQL, then SQL, through its automatic configuration and automatic monitoring and maintaining, it'll attempt to maintain between 4 and 10 meg of free physical memory. The remaining physical memory then gets used by the operating system and SQL Server itself. So when the amount of available bytes is near 5 megabytes or lower, potentially what you'll see is SQL Server will experience a performance hit due to the lack of memory. So what are you going to do when that happens? Well, you either need to increase the amount of physical RAM in the server, reduce the load on the server, or change the SQL Server memory configuration settings appropriately. And we'll talk about changing some of those settings in another session. So we've got that set there. Another one, another counter that you might want to put in here is the percentage disk time on a physical disk. So let's go ahead and have a look at that now. So under our performance objects, we'll go ahead and we'll choose physical disk. And you can see here now I actually have a choice. So I want to look at percentage disk time. So here it is, percentage disk time. Now, what I can do is, if I've got multiple disks, I can either select each individual disk or I can select all the disks in my array, in which case I'll select total and I'll add that. Now, I'm going to talk a little bit more in our summary about what the impact is of selecting the percentage disk time. But just as a guideline, the percentage disk time counter should run less than about 55%. If it runs more than 55% for a continuous period, and my definition of a continuous period is usually more than 10 minutes or so during a 24-hour monitoring period, then you may be experiencing an I/O bottleneck. Now, if you see this behavior only occasionally during the 24-hour monitoring period, it's not too much of an issue, but it happens often. If it happens often, then you need to look at ways of boosting your disk I/O performance on the server. So we've added our percentage disk time. Let's go ahead now again on our physical disk and we'll add our average disk queue length. So let's pop that in here. And same scenario, let's select that and choose add. Alright, so our average disk queue length is already in here. So again, you get the message telling you that there's no need to add that again. This is a fairly simple counter. And what you're looking for here with the average disk queue length is you're looking for to see if it's exceeding 2 for any continuous period. Again, our definition of a continuous period is more than 10 minutes in any 24-hour monitoring period for every disk drive in an array. If it does exceed 2, then potentially you have a bottleneck for that disk array. Again, you'll need to potentially do some calculations if you've got multiple disks in your array. We'll talk a little bit more about that though. So for example, if you've got 2 disks in the array and you do a total, then you'd want to divide the number you get by the number of disks to give you your specific disk queue length per disk. Next one we want to add is our processor. So let's go and we'll select on processor from our performance object, and we want to look at our percentage processor time. So again, if I've got a multiple processor machine, I can go ahead and select each individual processor, or I can select all processors. Important point to note here, if you do have a multiple CPU machine, you have the capability within SQL Server to tell SQL only to use certain processors, only to use a certain number of processors, which is important when you are licensing your SQL Server in per processor mode. So again, understand that will have an impact on the performance. If you have 4 processors, but you've only told SQL Server to use one of those, then potentially doing the monitoring across all processors isn't necessarily going to give you an accurate indication of what's going on. So you can see I've already added the percentage processor time into the performance monitor. So what are we looking for here? We are looking for the percentage total processor time not to exceed more than 80% for a continuous period, again 10 minutes, during our 24-hour period. If we are running into that issue, then potentially what you'll have is a scenario where you may need to add an extra CPU or look at doing some other work with your CPUs, and we'll talk about that in a second. Next one we want to add is the processor queue length. So this is a system object. So if I go in and I choose my system objects rather, and then I go ahead and I choose my queue length. So we'll choose our processor queue length and we'll add that. Now, this goes hand in hand with the percentage processor time counter. So you want to monitor the processor queue length as well. If it exceeds 2 per CPU for a continuous period, then you potentially have a CPU bottleneck. A couple of the other ones we want to add. SQL Server relies a lot for its performance on making sure it can retrieve data from a buffer. So we want to see how much data is being actually retrieved from a buffer versus how much the server has to go to the disk for. So let's go ahead and look at that. So this is going to be one of our SQL Server counters. So if I go in here, you'll see I have all my SQL Server counters, which only get added to a machine if I've installed Microsoft SQL Server. So if I look at my SQL Server buffer, let's just go ahead here and choose our buffer manager, and then we go ahead and we select our buffer cache hit ratio. So this is giving me the ratio between how much data gets pulled from the buffer and how much data gets pulled from the hard disk. Last one we want to add is a general SQL Server counter. So if I go here and I look under SQL Server General Statistics, one of the other things I want to look at is the number of user connections I have at any particular point in time. So let's go ahead and we'll add our user connections. Now, in your own time, you can obviously go ahead and look at even more of these different counters that you have, which can tell you a lot about exactly what's going on on your SQL Server. But right now, for the purposes of this session, I just want to show you some of the basics. So we've got all of those options selected. So I can now go ahead and I can choose close. So now what I have is I have a running performance counter. Now, a couple of things I would like to take you through. There's a couple of different ways of looking at this information that's being displayed by the performance monitor. You can look at it in this graphical view where you can see a consistently running graph. You have the ability to go ahead and view it as a histogram where you'll see each of the counters that you've specified actually running in this histogram view. The other way of looking at it is in a reporting view where you get a quick snapshot of the information that's being displayed at the bottom of the screen during the graph. So you can see my available memory going up and down, my number of pages per second, my physical disk time. So you can see there's not a lot of activity happening on my disk. You can see my average disk queue length. Remember we said we wanted this to be below 2, so that's tracking okay. My percentage processor time, so this is how much of the time is the processor is working on activating and taking care of tasks on the server. So again, I don't have this peaking up for extended periods of time, but again, of course, it depends on what's actually happening on the server at any given point in time. I have 7 connections through to my SQL Server, and my processor queue length is sitting between, as you can see, from 1 spiked up to 27 there. So, you know, that's not too bad. What I'm looking for, though, again, is having it sitting up higher than 2 for more than about 10 minutes. So you've got these different ways of looking at this information. So there's a couple of other things that you can do once you've got all your performance counters set in here. Once you've got those set, you can go ahead and choose File and then choose Save As, and you can go ahead and save this as a group of settings. So in which case I've got Richard SQL counter set, and I'll call this set 1, and because I've already saved a previous set, and I can go ahead and choose save, and that will create a file which maintains all of these counters for me. So next time I go ahead and start up Performance Monitor, I go Start, Administrative Tools, Performance. It's going to go ahead and start up into my default performance view. I can go File, choose Open, and then go through to the location where you've saved that, or you can go back up here under File and you can choose the set that you created, and you'll see that's automatically loaded back up for me, and it allows me to go ahead and run this set with those pre-configured counters put into the set for me. So again, once I've run this run this log for a period of time, I'm then able to go ahead and start doing my analysis. So at any given point in time during the analysis, you can see I'm tracking this information. What was the last recording? What's the average? What's the minimum? What's the maximum? And it's telling me the duration. So I can see that for this period of time, as at 1 minute and 40 seconds, these were the stats for my available bytes. So if I then want to look at that on my percentage processor time, I simply click on here, and you'll see that the information changes here. My last, my average, my minimum, maximum, and again my duration. I can look at my buffer hit my buffer cache hit ratio, and look at that information as well. Then also look at my user connections. So I can see the last counter was 7, the average was 7, the minimum was 7, and the maximum was 9. So again, I'm getting a pretty good picture of how that's floating, as well as my processor queue length. So once you've been running these counters for a period of 24 hours and you've logged that information through to a file, you can go ahead and you can look at this information that's being stored here, and then you can record it back in the table that we were talking about a little earlier. So now we've gone ahead and we've gone through the process of building our logs. Let's take a couple of seconds and let's go back and review exactly what the counters were that we captured and why we captured those counters. So again, the first one we did was our memory. We captured our pages per second, and this manages the number of pages, or memory pages that are moved from RAM to disk and from disk to RAM. Important point to note, if your paging counters go up, then that means your performance is going down. So your average should be around less than 20. If you have a situation where it is greater than 20, then potentially you've got a memory bottleneck due to a lack of needed RAM. Generally speaking, the more RAM a server has, the less paging it has to do. But again, bear in mind that there is an upper physical limit for the amount of memory that you can put into a server because of the limitations of the Windows operating system. So again, that's out of scope for this particular session, but in our session where we talk about server sizing, we'll talk a little bit more about that. One other thing that you might want to take a look at. If you've got a situation where you've got a physical server that's dedicated to SQL and it has an adequate amount of RAM, so as we said, the paging should average less than about 20. How do you determine also whether there's an adequate amount of RAM? You also want to look at the buffer hit cache ratio, which we'll look at in a little while, and make sure that's 99% or higher. If you have a SQL server that's got a buffer cache hit ratio of 99% or higher for your monitoring period of 24 hours, but you're getting an average paging level of over 20 during the same time, it might indicate that you're running other applications on the server other than the SQL Server application itself. So if that's the case, ideally you should remove those applications. Matter of fact, best practice is that on a server that's running SQL, SQL should be the only major application that's running on that physical server. If the SQL Server is not running any other applications and the paging is still exceeding 20 on average for a 24-hour period, it might mean that somebody has changed the SQL Server memory settings. So in a best practice scenario, SQL Server should be configured so that you are using the dynamically configure SQL memory option, and the maximum memory setting should be set to the highest level. So the reason for this is for optimum performance. You want to allow SQL Server to take as much RAM as it wants for its own use without having to compete for RAM with other applications. So again, SQL Server is fairly smart and it will try and keep itself running as best as it possibly can. So what's the next performance counter that we selected? Was our available bytes of memory, and again we said that we want that to be greater than about 5 meg, because on a dedicated server, SQL manages or SQL tries to maintain between 4 to 10 meg of free physical memory. If it is getting down below 5 meg of available memory, that's an indication that your server is memory bound and you need to add some additional server or change the SQL Server memory configuration settings. Again, I would leave changing the SQL Server memory configuration settings. Try and leave that alone if you can, because SQL is going to manage that pretty well itself. Next one is your physical disk, and this is your percentage disk time, which again we're looking for that to be less than 55%. If it's greater than 55% for more than about 10 minutes, then you might have some kind of I/O bottleneck which is existing on your disk drives. So how can you do this? If you're running a drive array, you can boost your disk I/O by adding drives. You can potentially look at adding faster drives, so drives with a faster access time, maybe a bigger cache on the drive. Maybe drives that operate a little bit faster. The faster the RPMs, the better the drive access will be. What you can also do is, depending on the controllers that you're running, the disk drive controllers in your server, if they are caching controllers, you can look at adding additional memory to those caching controllers. Again, allowing the controller to cache more of the reads and writes or more of the reads, more so to the hard drive. Next one we added was our physical disk length, or our physical on our physical disk, our average queue length, and we didn't want this to be any greater than 2 for a long period of time, which we said was more than about 10 to 15 minutes. Interestingly, sometimes you need to calculate this manually. For example, if you have an array of 6 disks in your machine, and your disk queue length is 10, as reported by performance monitoring, then you need to divide your disk queue length by the number of drives. So in this case, 10 divided by 6 gives you 1.66 as the counter per drive, which is less than our 2, so we get a gold star on that one. That's all okay. Next one we need to look at is the percentage processor time, which is available for each CPU. We talked about how many CPUs you've got allocated to SQL Server. And then again, an important point to note, if your percentage processor time is up over 80% for more than 10 minutes, then there's a good chance you've got a CPU bottleneck. What's the next thing you can look at is your processor queue length. Again, what are we looking at here with your processor queue length? This is really something which you're using in conjunction with the processor percentage time counter. So what you're looking at here is that this shouldn't exceed more than 2 per CPU for longer than about 10 minutes. If you do have multiple CPUs, then divide by the number of CPUs to get your CPU queue length. If you are getting it above 2, there's potential things that you can do. So what do I mean by that? If your processor queue length is regularly exceeding that recommended maximum of about 2, but your CPU utilization, the percentage processor time, is not correspondingly as high, so this is a typical situation that can happen, then you might want to consider reducing your SQL Server maximum worker threads configuration setting. Again, when you're starting to go in and tinker around with these settings on SQL Server, you want to be very, very careful. Why do you want to adjust this? Because potentially what you can have is an excess number of worker threads which are just sitting around waiting to take their turn. So potentially by reducing the number of maximum worker threads, what you're going to do is switch on the thread pooling to take advantage of that functionality in SQL Server. Importantly, if you look at both the processor queue length and the percentage total process time counters together, if both of those are exceeding their recommended amounts during the same continuous time period, then you can be 100% sure that you do actually have a SQL or a CPU bottleneck. Alrighty. Then we have our SQL Server buffer. And we looked at our buffer cache hit ratio, which was measuring how many times SQL goes to the buffer and not to the disk. For an online transaction processing server, this should be greater than 90% and optimally greater than 99%. So more than 99% of the time, SQL Server will be hitting the buffer to access the data. So obviously your database size is going to impact on this. And don't forget there is an upper limit on adding RAM in this particular scenario. So if you aren't able to get close to your 90 to 99% and you put the maximum amount of RAM in your server, then the only thing you can potentially do then is live with the consequences. So, just as a side note, if you are using online analytical processing applications, OLAP, like you're doing SQL analysis, the ratio can be much less because of the nature of how OLAP works. But in any case, putting more RAM in should increase the performance of SQL Server. But again, remember that you do have an upper limit on how much memory you can put into a server and how much memory your operating system can address. Next one that we looked at was our SQL Server user connections. So the number of users using SQL Server affects the performance, so you might want to keep an eye on the SQL Server user connections counter. This shows the number of user connections, not the number of users, physical users that are currently connected to SQL Server. If this counter does go up over 255, then what you might want to do is go ahead and boost your SQL Server configuration setting for maximum worker threads to a figure that's higher than the default setting of 255. Okay, so a good rule of thumb is that the setting for your maximum worker threads should be higher than the maximum number of user connections your server ever reaches. And of course, the only way you can determine that is by going ahead and running your performance logging and taking a look and seeing how that's tracking. So, we also want to talk about the benefits of building a baseline, and I also want to talk a little bit about a little technique called performance alerts. So the idea of the benefit of building a baseline is that it gives you really just that standard period where you can look and you can see how your server is performing on average. You can also then use that and run that baseline and then run different performance logs at different periods of time and compare the performance logs back to the baseline to identify periods where you've got a lower load on your server. Why would you want to do that? Well, what you can do is you can take that information and then you can say, I want to go ahead and schedule certain activities during these periods of lesser load. So, for example, if in my previous session I did on using database maintenance plans, then you run your maintenance plans during those periods of lesser loads. You can also use this for identifying rogue applications or users. A lot of the time when you suddenly run into a SQL Server performance issue that just suddenly kicks in, chances are it's potentially because someone started doing something which you weren't aware of. So again, having that baseline there to compare to is a handy thing. When you go ahead and you run a new performance log, you can compare it back to how things were running when performance was acceptable. couple of other things that you can do. There is the ability in the SQL Enterprise Manager on SQL 2000 or in the SQL Management Studio in SQL 2005 to create performance alerts. And how do performance alerts work? What performance alerts are all about is about being able to configure the server to tell you when certain performance thresholds are exceeded, and then the server can go ahead and send you an email and let you know that that's happened. For example, when the number of user connections does go above 255, you can go ahead and configure an alert so that you automatically receive an email telling you when that's happened. I talked a little bit about this concept of user settable alerts and using that for SAP Business One. So give you an example where that might be helpful. Again, important point to note, this is really only for advanced DBAs, because you can get yourself into all sorts of issues here when you use this user settable alerts and these user settable counters, that you can create a performance issue. So what's this all about? Give you an example. When you're performance tuning your SQL Server, sometimes it's handy to be able to measure some of the things as the number of the number of invoices entered per hour, or the number of checks that are being written per hour, or the number of times that a particular stored procedure might have run, or whatever the case may be. You can monitor these using the user settable objects, which is a set of 10 performance monitor counters that you can customize for your own ends. So creating the counters isn't hard, but you have to know how to program stored procedures. So again, very, very important that you have a good understanding of using Transact SQL. There are 10 SQL Server stored procedures called SP_user_counter1 through to SP_user_counter10, which you can use, which then go ahead and store the various values that your stored procedures will write into those counters. And then you can go ahead and use the alerts function to let you know when that threshold has been reached. Again, important point to note, don't overuse your user settable alerts, as they can cause server performance to deteriorate. And importantly, keep your stored procedures as simple as possible, because if you're running these really complex stored procedures to check when something's happening, just the process of running the stored procedure can cause the SQL performance to deteriorate. So that brings the session to a close. Just wanted to point you to a couple of specific additional resources on the web. Hopefully this session has been of use. We haven't gone deep into the whole performance monitoring topic, but there are many, many sites that you can go to. Again, one of the main ones that I use for my reference is SQLServerPerformance.com, which has some fantastic resources up there. Of course, don't forget that the two Microsoft websites, MSDN and the TechNet websites, contain some significant information. There's also some third-party database tools that you can use for managing and monitoring your SQL servers. One of those comes from a company called Quest Software, and they bundle all those tools together in the Quest Management Suite, or you can acquire each of those tools separately. And you can find them at www.questsoftware.com. And of course, don't forget you have your SQL books online. And in SQL 2005, I would particularly refer you to the chapter on monitoring and tuning for performance, which goes into a lot of the counters that are available for SQL Server in a lot more detail than I have in this session. So again, thanks very much for taking the time out to participate in this session, and I look forward to talking to you during our next session. Thanks.